Okay, students, so next is question number 18. So what it says, for what value of lambda? So you have to find basically lambda, right? So for what value of lambda is the function defined by this? So function given is this one, fx equal to lambda x square minus 2x if x less than equal to 0. Means if you take x less than equal to 0, this will be a function. If x greater than 0, this will be the function, okay? So is continuous at x equal to 0. So they have already given that this function is continuous at x equal to 0. So what will be the value of lambda, you have to find out, okay? Next part is, what about continuity at x equal to 1? Means at x equal to 1 you have to check the continuity of this function, okay? So let's try to find out. So what is given? Fx is continuous at x equal to 1. So what we understand from here? Now see, to find lambda I need equation, one equation of lambda. So let's see what equation I can get from the given information. So the information is fx equal to this one is continuous at x equal to 0. So from this what you understand? We understand that this graph of this function will not break at x equal to 0. So when your x equal to 0, the function, the graph means wherever it will be, this will not break. That's what they want to say, okay? So I have to use this information, I have to make equation. So in limit, how you will write down that? So fx is continuous at x equal to 0 means we understand at x equal to 0, left hand limit must be equal to right hand limit must be equal to f of when x equal to 0. Okay, so whatever is your function at x equal to 0, whatever value you will get, right hand limit also must be same, left hand limit also must be same, okay? So this will give you equation. So I have to get only one equation of lambda by any means, and in that equation lambda must be unknown, right? So let's see, left hand limit, what it will be? Limit x tends to 0 minus means you have to approach towards 0 from left. Then your function will tends to what value? You have to find that. It will tends to same value whatever you will get here. So right hand limit, let me write down first. Right hand limit is x tends to 0 plus. You have to approach towards 0 from right. Then your function will tends to what value? F of 0. F of 0 will be how much? F of 0 means x equal to 0. When your x equal to 0, which function you will take? X equal to 0, this will be the function. So f of 0 will be how much? Lambda x square. In place of x, 0. 0 square minus 2 into 0. So what? How much it will be? 0 minus 0, it will be 0 into 0 lambda. It will be 0. Okay. So we will get 0 here. So you can understand left hand limit. As you tends towards 0 from left, your fx will tends to 0. That's what we understand, right? As you tends towards x from towards 0 from the right, then your fx will tends to 0. That's what we understand. Okay, so from this only I have to make equation, right? So let me write down this one. What you will get, left hand limit, x tends to 0 minus means less than 0 you are approaching, less than 0, this will be the function. So let me write down the function here. Limit x tends to 0 minus fx is how much? Lambda x square minus 2 of x. Right hand limit will be how much? Limit x tends to 0 plus fx will be how much? Greater than 0 you are taking, right? X tends to 0 plus means what? Which value you will take? Just greater than 0, which are very close to 0, right? So it will be 0 0.01, 0 0.0001 like that you will take, right? So if you take greater than 0, which one function it will be? 4x plus 1 is equal to must be 0. Okay, so the equation it seems this and this, right? Okay, but there is one problem. You can see here they have said this is continuous, but see, if I take this 0 and put it here, what you will get? You will get 1 here, right? So if it is 1, let me write down first. 0 if I take and put it here, what you will get? 0 this one is equal to what you will get here? 0 if I put, you will get 1 here. This function will not be continuous actually. I don't know why they have given such kind of question. Anyway, since they have said this is continuous, we have to give one conclusion, right? Since they have said this is continuous and they have asked you to find lambda, what we will write down? Since it is not possible here, you can write down which is not possible. Which is not possible. Why not possible? Because they have already said it is continuous. This function is continuous, they have said, and we are getting that it is not continuous when you take x equal to 0 here. So this function will not be correct if you take lambda here. Okay, this will not be correct. So how we will write down the conclusion? Therefore there will be no value of lambda for which fx is continuous, or fx will be continuous, because it's not possible to find out lambda when your equation is not correct. This equation is not possible. You can see 0 cannot be equal to 1, right? And left hand limit, this is your right hand limit, this is your f of 0, and they are not equal, so obviously they are not continuous at all. But you cannot write down that it is not continuous simply, since they have said in the question it is continuous at x equal to 0. So obviously we are getting this one not equal to not continuous because of what? We will say that lambda, there should not be any value. Okay, it's not possible to find out from this equation lambda. Okay, because see, you can see from this portion only, to make equation of lambda must be there in the equation, right? And you are not getting any lambda here in the equation. Okay, and rest of this the information which is given here, from that you cannot make any other equation. These are the only equation I can make. Left hand limit equal to right hand limit equal to this one, and from this I am not finding any equation of lambda. So what we will write? Which is not possible. Therefore, why I have written, I hope you have understood, which is not possible. 0 equal to 1 equal to 0, this is not possible, right? Therefore, there will be no value of lambda for which fx will be continuous. Okay, so simple portion. But for this also you need understanding. Without understanding, I know this question will be complicated for you. So next part, again it is there. What about continuity at x equal to 1? So continuity at x equal to 1 means you have to check this function is continuous at x equal to 1 or not. So at x equal to 1, so let's find out. Let me write down in different page. So at x equal to 1, this we have already done, right? Limit, left hand limit, let's find out. Limit x tends to 1 minus f of x will be how much? Limit x tends to 1 minus. Now 1 minus means which value you will take? 0.9999 like that, right? Very close to 1 on your left. So 0.99 if you take means what? Greater than 0 value you will take. So x greater than 0 means which function? 4x plus 1, which is equal to how much? Now 1 can I put directly because this is defined value, right? I hope you can understand. This is from tabular form we used to put. Okay, simply don't think that we are putting 1 here. This is just a shortcut. I have already told you in class 11. Actually what we are doing is we are taking in place of x which value? The values which are on your left of your 1, which is very close, that is 0.9 we will take here. X equal to 0.9 if you take, what will be your fx? We are finding that one. This is your fx, right? If you take 0.9, what will be fx? Put it 0.9 here, okay, and try to find out some value. Then 0.99 means keep on coming closer towards 1. X, you take those value which will be close to 1 from your left. So 0.999, come closer towards 9. Oh, I mean 1. 999 like this. So it is approaching towards 1, right? You can see 0.9, 0.99 approaching towards 1. Then if you take this kind of value in place of x, what will be your fx tends to? So try to put 0.9 here. You will get something here, value. Okay. Let me tell you. It will be something like this. 4.999 like this you will get. Here you will get 4.99999 like this you will get. Here you will get 4.99999 like this you will get. 4.999 means it is coming closer to what value? 5. Okay, it is coming closer towards 5. So this is how the meaning of this one it is. Okay, actual meaning. But see, you can write down this one simply like this also. So answer, what it will come? As your x tends towards 1 from your left, fx, what we will write? it will tend towards 5. So it will be, answer here will be 5, right? So simply that 5, how I can get? 1 if you put here directly, you can get 5 or not. So that is shortcut here. Okay, so from this statement what we understand, x tends to 1 from your left, then your fx will tends to 1. This is what the actual meaning. This we have studied in class 11 only, tabular form. Okay. So left hand limit, what you got? 5. So let's see right hand limit what I will get. You have to check continuity at x equal to 1. So at x equal to 1, if your left hand limit, right hand limit and f of 1, if it is same, then it will be continuous. So right hand limit x tends to 1 plus f of x is equal to limit x tends to 1 plus. 1 plus means greater than 1 you are taking. So greater than 1 means which function? This one, x greater than 0. This is the function, right? Again 4x plus 1. So obviously you will get here 5 only. 1 we will put directly, right? So try to understand this also with tabular form. Why I am saying this? Because in some question directly you cannot put it. You need to understand this one logically, okay? So let's find out f of 1. I will show you in which kind of question you cannot put directly 1. In this I've put directly, right? But see, to understand this one exactly, what we are doing is you are taking which value? 1.9 or close to 1, right? On your right. So which value it will be? 1.01. Then more closer if you have to come, what you will take? 1.001, like that you will take, right? So x, if you take 1.01, 1.001, 1.0001, like this if you take, so what it is approaching, you can see it is approaching towards 1. So I have to take that kind of value. As your x tends to 1, as your x tends to 1 from your right, you can see, okay, what your fx will tends to. So if you take x equal to like this, what you will get fx, you find out, and you will see that it will approach towards 5 only. You will get here 4.9, 4.99, like that you will get, and finally it will approach towards 5. So that's why we got 5 here. Okay, so simply we are putting 1 here whenever it is defined value like this. Okay, but in some cases you cannot put. I will tell you in next question only it is there. Okay, so f of 1, it is how much? So x equal to 1. Equal to 1 means greater than 0, right? So this will be the function again. So 4x in place of x, 1 plus 1 is equal to how much? 5. You can see left hand limit, right hand limit, f of 1 all are same. Since limit x tends to 1, f of x is equal to f of 1. This was the definition, right? You can write like this, or simply you can write left hand limit, right hand limit equal to this. No problem, you will get same marks for that. Since this is equal, therefore f is continuous at x equal to 1. That's it. So this kind of question we have done before also, and please don't jump. The video when you will watch, try to watch in sequence, otherwise this topic is not that simple to understand. Okay, so if you skip those videos, obviously in the upcoming video you are going to face problem. Okay, so this question is very tricky. You need to understand this very carefully. Okay, the way we have solved previous question, exactly same way you cannot solve this one. You have to use logic here properly. Okay, so see what it says. Show that the function defined by gx, now this is your function, gx is equal to x minus, what is this, greater integer function, right? This, remember symbol, greater integer function. This means what? If you take any integer x here, not integer, whatever value, real number you will take, suppose 1.9, if you take, what will be the outcome here? The outcome will always be integer. Okay, the outcome of this one will be always integer. Now which integer value? If you take a number line, 1 point, this is 1 suppose, so 1.9 will be somewhere here, next will be 2. Okay, so on your left, whatever is the greatest integer, that will be the outcome here. So 1.9 is here, so what will be the greatest integer here? 1. Greatest, why it is say, you can see on your left, this will be the greatest integer. Okay, so 1.9, so 1 will be the greatest integer here, so that's why the outcome will be 1. If it is integer only, say 2, this is 1, then the outcome will be how much? It will be 2 only, because this itself is integer, so this will be the greatest integer from your left. So you can see 2 will be the greatest integer of all this left values. Okay, in this case 1.9 was not integer, right? So which one will be the integer you will take? On your left, the greatest one. So 1 will be the greatest integer on your left. So always on your left, don't take from the right. Okay, so this was the function defined. When we have studied in class 11, we have already studied about this function. Okay, greatest integer function, we have already studied about this, so you need to understand that. Okay, so show that the function defined, this one, is discontinuous. So you have to show that this function which is given, the graph of this one will break. You have to show that. Discontinuous means what? Break. Graph will break like this. Where? At all integral points. Means you have to show that when you take all integral points, means x, if you take 1, 2, 3, 4, minus 1, minus 2, minus 3, all those integer value if you take, you have to show that there the graph will break. Here graph will break like this. Here graph will break like this. Let me draw a big one. This is 1, suppose. 2, here the graph is something like this, it's coming like this, suppose. Then at 1 what will happen? The graph will break like this. And when it about to reach 2, then the graph will again break. When it will about to reach 3, then the graph will again break. So you have to show that at integer value the graph will break, means it is discontinuous at all integer value you have to show. Okay, so how you will show? Obviously we cannot show one by one like this, right? Infinite integers are there, so in general I will show. Okay, so for that what I will show? I will simply take general value, like say let n general, n belongs to integer, I will take. Okay, so n is what? Integer value. You have to understand this question carefully. See here, this is integer value I'm taking. It can be 1 or 2 or 3 or 4 or 5 or 6, anything it will be, but it will be integer. Okay, so for this I will show that this graph will break. Now graph will break, how I will show? Simple, left hand limit, right hand limit, n. F of n we will find out, right? And we will show that they are not equal. Okay, so how we will do? So left hand limit I will show. So at x equal to n. Remember I'm taking a general. Okay, n can be any integer, 1 or 2 or 3 or 4, 5. So see, for all integer I have shown in ones. Okay, at once I have shown this. Okay, so see here. So x equal to n means any integer. So left hand limit, let's find out for this. Right hand limit, let's find out for this. And f of n, let's find out for this. Now you have to be very careful with this. Left hand limit, right hand limit, and f of n when you will find. So see here, left hand limit, what was the definition? Limit x tends to n minus f of x. Now what will be? Not f of x, sorry, g of x. This time function they have defined by g, right? G of x is equal to, right hand limit, what you will write? Limit x tends to n plus g of x. See carefully, f of n, in place of x we have taken n, so it will be n minus n. Okay, so see carefully. Now n is integer, right? So if it is 1, then it will give you output also 1 only here, and this obviously 1 minus it, so it will be always 0 for sure, because this is integer here. But in this case it is different. Remember I told you, that's why in question number 18 I have explained this one again. X tends to n plus means what? N is suppose 5. Then x, which value you will take? Suppose 5, this one. You will take those values which are very close to 5 on your right, plus, right? So on your right. So 5.01, 5.001, 5.0001. You will come closer towards 5 from your right if it is 5. If it is 2, then also same, 2.01, 2.001, you will come closer towards 2. Like that. You are taking point values here. You are not taking integer here in place of x. Try to understand that. Okay, so let's do first this one. Left hand limit. Limit x tends to n minus. So gx is how much? Limit, let me write down the function only. X n minus. Gx is how much? X minus x. right? Now see when I will put the value. Don't simply put n now. If you put n, obviously you will get 0 here, but we cannot put n here because this is greatest integer function. You know that if you take n point value, then also it will give you integer value. So obviously by putting n, whatever value you will get, by putting different value here, you will get different value. I hope you can understand what I'm saying. So see, I will give you example for this also. That's why I said simply putting the value will not help you finding answer. So in this case, directly you cannot put n here. See why. Now see, x, what value I will take, and fx, what it will tends. You have to find out. So x, as it tends towards n. And suppose I will take, for example, 10. So which value I will take? From your, this one is from your left, right? So which value I will take? 0 0.9. 9.9. 9.99. Can you see I'm coming closer towards 10? 9.999. This kind of value will take, right, in place of x. Then what will be your fx? You have to find out that. So see carefully fx, what it will be. When you will take x 9.9, okay, what will be your fx? Not fx, gx, this one. What will be your gx? So gx will be, in place of x, what you are taking? 9.9 minus 9.9. This will be your gx, first one. Second, in place of x, what you are taking? 9.99. So what will be your gx? Gx is this one, right? X, when I take 9.99, gx will be 9.99 minus 9.99, greatest integer function, this one. Find out this. 9.999, 9.999. Find out. This also find out. 9.999, 9.999 integer. Find out. So see, if I find out this value, what you will get? 9.9 minus this one will, how much it will give? Exactly 9. So what you will get? 9.9 minus 9. Greatest integer function, right? 9.9, what it will give? You can see number line. This is 9, suppose. 9.9 will be somewhere here. Then next integer will be 10. So the greatest integer here will be what? On your left, 9 will be the greatest integer. So output of this one will be 9. So 9.9 minus 9 will be how much? 0.9. Can you see? So this will be 0.9. Next, if you find out what you will get, here what you will get, again 9. This will be 9.99 minus this, again it will give you 9, right? 9.99 also will be somewhere here. Next integer will be 10. So on your left, the greatest integer will be 9. So 9.99 minus 9 will be how much? 9.99 minus 9. How much it will be? 0.99. Can you see? This will be 0.99. I hope you can see. Next, this one how much you will get? 0.999. This one how much you will get? 0.9999. So you can see it is approaching towards what? 1. So in this case, what will be the answer? 1. Even if you take, I am taking here n 10, right? Take 5. Try to see. If it is approaching towards 5, this is integer, right? In general form I am showing. So any integer you take here and try to see. It will always approach towards 1. You can see for 5 also. 4.9, 4.99, 4.999. Then fx you try to find out. 4.9 minus 4.9. How much it will be? 4.9 minus this, how much it will give? 4. So it will be 0.9. Can you see? Next will be again 0.99. So it is always approaching towards 1. So what will be the answer for this? 1. So see, if you simply put n here, n means what? Integer. So you will take this one, output also will be n, this also n. So n minus n, it will be 0. But the answer is not 0 here. You can see. That's why you need to understand this portion, limit portion, logically. Don't just memorize it. If you memorize, I told you in the beginning only when I was explaining this, if you memorize some question, you can solve, no problem. But in some question, you will be in trouble. Okay, like this question. You will get confused, those who have not understood limit. So if you have doubt, ask me there. I have already uploaded limit video also, which I have explained in class 11. Okay. So you see those videos and try to understand limit well first, then only try to solve all these questions. Okay, so right hand limit also let's find out. So limit x tends to n plus means greater than n you will take, right? Gx is x minus greatest integer function. So let's find out. N plus means take one integer and try to see what gx will tends to, what will be the answer for this. And don't put it, because in place of x, when we used to put n, when you will get c in tabular form, when you will get it is approaching towards 1, and by putting in place of x this value, if you get 1 in this case, then we used to put directly, but in this case you will not get, because since if you put n directly here, you will get 0 here, but the answer is 1. With the help of tabular form we have understood that. Okay, so in this case also let's try to understand with tabular form. So n plus means what? Greater than n you will take, right? Just greater than. So take any integer, say 10 again. So what kind of value you will take? 10.01, 10.001. You will approach towards 10, right? 001 x. Then your fx will approach towards what value? So not fx, again I'm writing fx, gx. So 10.01 minus greatest integer function of this one, 01. What it will be? This will be 10. This will be how much? 10.01. So it will be how much? 0.1. 0.01. Right? 10.01 this one, and this will be 10, right? So 10.01 minus 10, how much it will be? 0.01. So this you find out 0.001 you will get. This one 0.001. So towards what value it is approaching? It is approaching towards 0, right? So as your x tends towards 10, your gx tends to 0. You can take here 5. For 5 also, if you take 5.015, so what will change? In place of this 10 only you have to put 5, right? So answer what you will get here, 5.01 minus 5, this will be 5. 5.01 minus 5, what you will get? 0.1 only, right? So again it will tend towards 0 only. So what will be the answer here? 0. You can see they are not equal. So obviously discontinuous. Already you got the answer. So you can see left hand limit, right hand limit, and f of n is not equal. So in this part you can see only 3 lines I have written, but the concept is very high here. Logic you need to use very high here. Okay, you cannot simply memorize these things. So what we will write, conclusion, since left hand limit is not equal to right hand limit is not equal to f of n. Simply I will write like this, or you can write like this also. Limit x tends to n, f of x is not equal to f of n. Therefore, not f, sorry, why I am writing only f, g. Okay, therefore g is discontinuous at all integral value, you can write. Okay, so you see this video, try to understand this question, and if you have any doubt you can ask me. Okay.